Hey everybody, welcome back to my channel. This is WireDogSec and I'm back with another video for you guys. Today's video, we are continuing on with the TryHackMe Pre-Security Learning Path Linux Fundamentals. This is Linux Fundamentals Part 3. Power up your Linux skills and get hands-on with some common utilities that you are likely to use day to day. Now, let's go ahead and dive into it. Task number 1, Introduction. Welcome to part 3 in the finale of the Linux Fundamentals module. So far, throughout the series, you've got hands-on with some fundamental concepts and used some important commands. This room is going to showcase some useful utilities and applications that you are likely to use day to day. You're also going to advance your Linux foo skills by learning about automation, package management, and service/application logging. Let's proceed. So let's go ahead and do that. As you can see there, attack machine is firing up right now. I've already clicked the green button here to deploy the Linux machine. So I'm going to go ahead and skip past this here. And after we've logged into it, do an SSH. I'm going to hit complete here. So I'm wait till this fires up, and we'll come back and continue on with task number 3 here. Hey everybody, just a quick little blurb here. As you can see here, most people that view my channel are not subscribers. If you're new here, please consider subscribing to the channel. If you're enjoying the video, please consider hitting the like button. It helps get me in the algorithm, helps spread the good word out there, helps bring more people and increase our glorious community here. All right, I'm all about helping out others. I know what it's like to come up in cybersecurity or even try to get into cybersecurity and not knowing where to look. I'm just having this channel up so I can help out other people. All right, that's all I got. Task number 3, terminal text editors. Throughout this series so far, we have only stored text and files using a combination of the echo command and the pipe operators. This isn't an effective way to handle data when you're working with files in multiple lines and the sorts. Introducing terminal text editors. There are a few options that you can use, all with a variety of friendliness and utility. This task is going to introduce you to Nano, but also show you an alternative named Vim, which TryHackMe has a room dedicated to. I personally prefer Nano over Vim. Nano. It is easy to get started with Nano. To create or edit a file using Nano, we simply use Nano in the file name, replacing file name with the name of the file you wish to edit. All right, so make sure you guys are following along here. Clear this stuff out of here. All right, so we're going to do Nano and my file as it shows there. There we go. See, it pulled it open here. Once we press enter to execute the command, Nano will launch, where we can just begin to start entering or modifying our text. You can navigate each line using up and down arrow keys or start a new line using the enter key on your keyboard. And there's an example here. I can write things into my file. So I'm just going to type in some stuff here. Hello, TryHackMe. All right. You can go down a line like it shows in there. I can write things into my file. There we go. Nano has a few features that are easy to remember and covers the most general things you want to want out of a text editor, including searching for text, copying, pasting, jumping to a line number, finding out what line number you are on. You can use these features of Nano by pressing the Control key, which is represented as a caret on Linux, and a corresponding letter. For example, to exit, we want to press Control and X to exit Nano. All right, as you can see there, this is what they're talking about here, right? So if we want to X out of here, hit Control and X, and it says you want to save it. I'm just going to go ahead and hit yes, save it. And now we're going to get into Vim. Awesome. Vim is a much more advanced text editor. Whilst you're not expected to know all the advanced features, it's helpful to mention it for powering up your Linux skills. Some of Vim's benefits, albeit taking a much longer time to become familiar with, includes customizable syntax. Highlighting Vim works on all terminals where Nano may not be installed. There are a lot of resources such as cheat sheets, tutorials, etc. TryHackMe has a room showcasing Vim if you want to learn more about this text editor. So be sure to check out Vim if you're interested in that. I'm just going to hit complete here. Edit task 3 located in TryHackMe's directory using Nano. What is the flag? All right, so let's see where we're at now. Let's do pw print working directory. Awesome. ls. There's task 3, so use Nano and then task 3. There we go. So you can just go ahead and grab this out of here. Let's see if it lets me do it this way here. All right, if I can grab it. Let's see. There you go. Awesome. Now let's go ahead and exit out of this file here. Let's see. You can do the same with Vim. Let's, yeah, see, same thing. All right. Now let's go ahead and continue to task number 4 here. And we're going to talk about general/useful utilities. Downloading files using wget. A pretty fundamental feature of computing is the ability to transfer files. For example, you may want to download a program, a script, or even a picture. Thankfully for us, there are multiple ways in which we can retrieve these files. We're going to cover the use of wget. This command allows us to download files from the web via HTTP as if we were accessing the file in your browser. We simply need to provide the address of the resource that we wish to download. For example, if I wanted to download a file, name my file.txt onto the machine, assuming I knew the web address, it would look something like this. You got wget and then the URL for it. Transferring files from your host, SCP, SSH, secure copy, or SCP is just that, a means of securely copying files. Unlike the regular CP command, this command allows you to transfer files between computers using the SSH protocol to provide both authentication and encryption. Working on a model of source and destination, SCP allows you to copy files and directories from your current system to the remote system, copy files and directories from your remote system to your current system, provided that we know usernames and passwords for a user on the current system and a user on the remote system. For example, let's copy an example file from our machine to a remote machine, which I have neatly laid out in a table below. All right, and there's the information that you need here: IP address, remote system, local system file, and then remote system file where you're going to save it as. With this information, let's craft our SCP command, remembering that the format of SCP source destination. All right, and now let's reverse it by this layout using SCP to copy a file from a remote computer that we're not logged into. All right, so you're going to do the opposite here. And then it goes and talks about curl, wget stuff here. Ubuntu machines come prepackaged with Python 3. Python 3 hopefully provides a lightweight and easy to use module called HTTPS or HTTP server. This module turns your computer into a quick and easy web server that you can use to serve your own files, where they can be downloaded by another computing user or using commands such as curl and wget, Python 3's wt. A server will serve the files in the directory where you run the command, but this can be changed by providing options that can be found with the manual pages. Simply, all we need to run is python-m http.server in the terminal. To start the module in the snippet below, we are serving from a directory called web server, which has a single named file. And there's an example here of what it looks like. Now let's use wget to download the file using the 10.10.134.46 address, the name of the file. All right, so let's go ahead and start up this web server here, Python 3-m http.server. All right, there we go. And this is now, let's use wget to download the file using the 10.10.134.46 address, the name of the file. So let's go ahead and try that out here. I assume it wants us to do this here, so let's go ahead and try that. Just going to copy and paste things over here. All right. And it says it was saved. So let's do an ls, and there's my file. There we go. Awesome. Note, you will need to open a new terminal to use wget, which I've already done here. And we've already downloaded it, so we've already gone through all this here. Remember, you will need to run the wget command in another terminal while keeping the terminal that is running Python 3 server active. Examples below, we've already gone through here. One flaw with this module is that you have no way of indexing, so you must know the exact name and location of the file that you wish to use. This is why I prefer to use updog. What's updog? A more advanced yet lightweight web server. But for now, let's stick with using Python's HTTP server. So be sure to check out updog if you're interested in that. So let's go ahead and answer some questions here. Ensure that you're connected to the deployed instance. Yep. Now use the HTTP server module, start up the web server, home directory, and use the Okay, directory of the TryHackMe user and the deploy device, which I've already done here, and then download the file flag. Okay, so let's go back over here, and I'm pretty sure we are in the home directory, but let's go ahead and clear this out here. So let's do this. All right. Yep, home directory of the TryHackMe user. So this should be it. Let's go ahead and start this back up here. All right, so let's go ahead and try to download this flag. I'm just gonna try to copy and paste this over here. Let me clear all this out of here, and then wget, and paste. There we go, awesome. And let's see here. It's a hidden file, I believe, so that's probably why we can't see it in here. Yep, there it is. So let's just go and do that. Copy, clear all this stuff out here, and then cat. Go here, and there we go. Well, awesome. So now that we have this on this flag answer, we can go and continue on here and create and download files to further apply your learning. See how you can read the documentation. Use Control C to stop it. So be sure to check this out, play around with it a little bit, get familiarized with it, etc., etc. We're going to continue on to task number 5 here. And we're going to be talking about processes 101. Processes are the programs that are running on your machine. They're managed by the kernel, where each process will have an ID associated with it, also known as its PID. The PID increments for the order in which the process starts, i.e. the 60th process will have a PID of 60. Viewing processes. We can use the friendly PS command to provide a list of running processes as our user session and some additional information such as its status code, the session that it's running, how much usage time of CPU is using, and the name of the actual program command is executed. So let's go ahead and clear this out of here, and you can do PS like that. And there you go. Let's see here. Note how in the screenshot above, the second process PS has a PID or PID of 204. And then in the command below, this is then incremented by 205 as shown in the screenshot here. And to see the processes run by other users and those that don't run from a session, i.e. system processes, we need to provide the AUX to the PS command like so. So let's go ahead and do that. Clear all this out of here. PS, AUX, see everything, right? And let's see here. Note, we can see a total of 5 processes. Note how we have root and cmnatic. Another very useful command is the top command. Top gives you real-time statistics about the processes running on the system instead of one-time view. These statistics will refresh every 10 seconds, but will also refresh when using the arrows to browse to various rows. Another great command to gain insight into your system is via the top command. All right, so let me go ahead and kill this here. Clear this out. You can do the same thing from the box you're on. All right, so P AUX. There you go. Out and top. There you go. And then quit out of here. Let's continue on. Managing processes. You can send signals that terminate processes. There are a variety of types of signals that correlate exactly how cleanly the process is dealt with by the kernel. To kill a command, we can use the appropriately named kill command and the associated PID that we wish to kill, i.e. to kill PID 1337, we need to use kill 1337. Below are some of the signals that we can send to a process when it is killed. You got sig term, kill the process, but allow it to do some cleanup tasks beforehand. Sig kill the process, doesn't do any cleanup after the fact. Sig stop, suspend the process. How do processes start? Let's start off by talking about namespaces. The operating system OS uses namespaces to ultimately split up the resources available on the computer to such as CPU, RAM, and priority processes. Think of it as splitting your computer up into slices similar to a cake. Processes within that slice will have access to a certain amount of computing power. However, it will be a small portion of what is actually available to every process overall. Namespaces are great for security as it is a way of isolating processes from another. Only those that are in the same namespace will be able to see each other. We previously talked about how PID works, and this is where it comes into play. The process with an ID of 0 is a process that is started when the system boots. This process is the system's init on Ubuntu, such as systemd, which is used to provide a way of managing a user's processes and sits in between the operating system and the user. For example, once a system boots and initializes, systemd is one of the first processes that are started. Any program or piece of software that we want to start will start as what's known as a child process of systemd. This means that it's controlled by systemd, but will run as its own process, although sharing the resources from systemd will make it easier for us to identify and the likes. And there's the example there, and we can see it over here as well, systemd, right? Let's continue here. Getting processes/services to start on boot. Okay. Some applications can be started on boot of the system that we own, for example, web servers, database servers, and file transfer servers. This software is often critical and is often told to start during the boot up of the system by administrators. In this example, we're going to be telling the Apache web server to be starting Apache manually and then telling the system to launch Apache 2 on boot. Enter the use of systemctl. This command allows us to interact with systemd, process/daemon. Continuing on from example, systemctl is an easy to use command that takes the following formatting: systemctl option service. For example, to tell Apache start, we'll use systemctl start Apache 2. Seems simple enough, right? Same for if we wanted to stop Apache, we'd use just replace the option with stop instead of start, like we provided. We can do 4 options with ctl: start, stop, enable, and disable. An introduction to backgrounding and foregrounding in Linux. Processes can run in 2 states, into the background or in the background and the foreground. For example, commands that you run in your terminal, such as echo or things of that sort, to run in the foreground of your terminal, as is the only command provided that hasn't been told to run in the background. Echo is a great example, as the output of the echo command will return to you in the foreground, but wouldn't in the background. Take the screenshot below, for example. All right, echo hi thm, echo hi thm, and which is supposed to background it, right? But it still shows up here. All right, here we're running echo hi thm, where we expect the output to be returned to us like it is at the start, but adding the and operator to the command, we're instead giving it the ID echo process rather than the actual output as is running in the background, right? This is a great for commands such as copying files, because it means that we can run the command in the background and continuing on with whatever further commands we wish to execute without having to wait for the file copy to finish. We do the exact same when doing or executing things like scripts. Rather than relying on the AND operator, we can use Control-Z on our keyboard to background a process. It is also an effective way of pausing the execution of a script command like below. You see there it says stopped. The script will keep on repeating. This will be on loop until I stop or suspend the process by using Control-Z as indicated, T-Z. Now our terminal is no longer filled up with messages until we foreground it, which we'll discuss below. Foregrounding a process. Now that we have a process running in the background, for example, our script background.sh, which can be confirmed using the ps aux command, we can backpedal and bring this process back to the foreground to interact with our process background using either Control-Z or the AND operator. We can use the FG for foreground to bring this back to focus like below, where we can see the FG command is being used to bring the background process back to the terminal, where the output of the script is now returned to us. And you can see there it's back displayed to the user. All right, it says readme. If we were to launch a process where the previous ID was 300, what would the ID of this process be? All right, so it said the previous ID was 300, so the new process would be 301 because it's incrementing, remember. If we wanted to cleanly kill our process, what signal would we send? And I believe that was sig kill. We can always scroll back up. Yep, or sig term. There we go. Okay, sig kill is the one without any cleanup afterwards. So go ahead and copy and paste that in there. There we go. Locate the process that is running on the deployed instance. What flag is given? So let's scroll through here and take a look. Okay, managed to find the flag by using ps aux, right, AUX in here. And as you scroll down, you'll come across it right here, THM processes. For some reason, it was not showing up when I did the first time, so I had to reboot or completely close and relaunch the Linux machine that we SSH'd into. I accidentally read over some of this or skipped some of this part here, so let's just go back and take a look here. What command would we use to stop the service, my service? Well, that's going to be systemctl, right? Remember, and then stop, and then the name of the service, which would be my service. And then what command would we use to start the same service on the boot up of the system? Well, it's going to be systemctl enable my service. All right, there you have it. And then also, what command would we use to bring a previously background process back to the foreground? Remember, to foreground a process, you have to use the fg command. And then also the same thing for the attack box. So not sure what happened there. But anyway, task number 6, maintaining your system automation. Users may want to schedule a certain action or task to take place after the system has booted. Take, for example, running commands, backing files, or launching your favorite programs on such as Spotify or Google Chrome. We're going to be talking about the cron process, but more specifically, how we can interact with it via the use of cron tabs. Cron tab is one of the processes that is started during boot, which is responsible for facilitating and managing cron jobs. Now, cron jobs are basically the equivalent of scheduled tasks in Windows boxes. All right. And here's an example of what it looks like here. Cron tab. Cron tab is simply a special file with formatting that is recognized by the cron process to execute each line step by step. Cron tabs require 6 specific values. You got min, what minute, hour, what hour, dom, what day of the month, mon, what month of the year, dow, what day of the week, cmd, command that will be executed. Let's use the example of backing up files. You may wish to back up CM NATIC documents every 12 hours. We would use the following formatting. An interesting feature of cron tabs is that these also support the wildcard or asterisk. If we do not wish to provide a value for the specific field, we don't care. That month, day, or year is executed only if it is executed every 12 hours. We simply just place an asterisk. This can be confusing to begin with, which is why there are some great resources such as the online cron tab generator that allows us to use a friendly application to generate your formatting for you, as well as the site Cron Guru. Cron tabs can be edited by using crontab-e, where you can select an editor such as Nano to edit your cron tab. And there's an example here, another example here. Ensure you are connected to the deployed instance and look at the running cron tabs. So let's go ahead and do that here. All right, let's go ahead and clear all this out. Okay, so let's go ahead and take a look at this cron tab-e, so we can find out inside of here. And if we scroll all the way down to the bottom here, we can see this at reboot section here. So let's see here. Sure, you are connected. We already did this. Okay. We're looking at the running cron tabs. When will the cron tab on the deployed instance run? Well, this means this is going to run at reboots every time it reboots. So let's go ahead and type that in here. There we go. All right, task number 7 here. Maintaining your system package management. Introducing packages and software repos. When developers wish to submit software to the community, they will submit it in an apt repository. If approved, their programs and tools will be released into the wild. Two of the most redeeming features of Linux shine to light here: user accessibility and the merit of open source tools. When using the ls command on an Ubuntu 20.04 machine, these files serve as the gateway/registry, and then there's an example here, ls, inside of this apt area here. It's got all the files listed out. They got the sources.list, right? That's where it's pulling some stuff from. That's what it looks like here. And let's go ahead and continue on here. Whilst operating system vendors will maintain their own repositories, you can add community repositories to your list. This allows you to extend the capabilities of your OS. Additional repositories can be added by using the add apt repository command, or by listing another provider. For example, some vendors will have a repository that is closer to their geographical location. Managing your repositories, adding and removing. Normally, we use the apt command to install software onto our Ubuntu system. The apt command is a part of the package manager software named apt. Apt contains a whole suite of tools that allows us to manage the packages software or sources of our software and to install or remove software at the same time. One method of adding repositories is to add apt repository command we illustrated above. As well as you can install software through the use of package installers such as dpkg. The benefits of apt means that whenever you update our system, the repository that contains the pieces of software that we add also get checked for updates. In this example, we're going to add text editor Sublime text to our Ubuntu machine as a repository, as it is not part of the default Ubuntu repositories. I'm going to skim through a lot of this here. So be sure to check out this video and read through this thoroughly. All right, just for the sake of time, I'm going to just skim through a lot of this. So to start, we need to add the GPG key to developers of Sublime Text 3. Note that TryHackMe instances do not have access to the internet, and so we're not expecting you to add this to your machine that you deploy, as it will fail. All right, so if you want to go through this on your own machine that you control in like VMware or something like that, you can go ahead and do that, but obviously you cannot do this because there's no access to the internet. So I'm going to go ahead and just skip over this section here. All right. So be sure to read through this. After you've done that, go ahead and click correct answer and then continue on to task number 8. All right, maintaining your system logs. We briefly touched upon log files and where they can be found in Linux Fundamentals Part 1. However, let's quickly recap. Located in var log directory, these files and folders contain log information for applications and services running on your system. The operating system, OS, has become pretty good at automatically managing these logs in a process that is known as rotating. I have highlighted some logs from 3 services running on Ubuntu machine, Apache 2 web server logs for the fail to ban service, which is used to monitor attempts. Brute force attempted brute forces, for example, the UFW service, which is used as a firewall. And here's an example, right? You got Apache 2 here, and you got the fail to ban.log. It's going to be log file. Then UFW for the, I believe that stands for universal firewall.log. So that's going to be that file. All right, this says these services and logs are a great way in monitoring the health of your system and protecting it. Not only that, but the logs for services such as web server containing information about every single request, allowing developers or administrators to diagnose performance issues or investigate an intruder's activity. For example, the 2 types of log files below that are of interest: access logs and error logs. And here's an example of where they're located. Access logs right there, and there's error log. There are, of course, logs that store information about how the OS is running itself and actions that are performed by users, such as authentication attempts. All right, let's check out these questions here. Look for the Apache 2 logs on the deployable machine. All right, so let me get out of this real quick. All right, let's clear this out of here. So they said they're in var log, right? Let's go ahead and try to navigate to that. So cd, see if we can do it this way here, var log. All right, ls, and there we go. There's Apache 2. All right. And what is the IP address of the user who visited the site? All right, so let's go ahead and see here. Let's get into Apache 2. All right, clear all this stuff out of here. All right, so let's go ahead and maybe do a cat on access.log. Permission denied. Well, okay. Let's see. Let's go back here. What's this one? Let's see. Ah, okay. Now let's see here. Cats and dogs, JPEG. And here's the IP, apparently. So go ahead and copy this out of here and paste. There we go. What file did they access? Well, they accessed this dogs and cats JPEG file. So copy and paste this over. And there we go. Now, let's go ahead and wrap up this video. Task number 9, conclusions and summaries. Welcome to the end of the Linux Fundamentals module. Your familiarity with Linux will improve as you get to interact with it over time. Linux has the potential to do very powerful things with relative ease, as you have hopefully discovered throughout this module. To recap, in this room, the following topics were covered: using terminal text editors, general utilities such as downloading and serving contents using a Python web server, a look into processes, maintaining and automating your system by the use of cron tabs, package management, and reviewing logs. Continue your learning in some of the other TryHackMe rooms that are dedicated to Linux tools and utilities, bash scripting, and regular expressions. So be sure to check these out and dig into this if you are curious about Linux. I recommend checking out these rooms. It can only benefit you, right? And let's wrap this up here. Terminate the machine. Okay. Continue to other Linux dedicated rooms here. So that wraps up this video, folks. If you found this video of value and you're new here, please consider hitting that subscribe button with the notification bell. Hit the like button if you enjoyed the video. Comment below your thoughts and opinions. As always, thank you for watching. Have a nice one, and I will see you later.